Maybe to you it's not surprising at all that these basic problems, like incidences between points and lines, that maybe Euclid could have worked on, find applications in mathematics. So beforehand we talked about the other direction, right? We talked about using tools from mathematics, from algebra, topology, etc., to solve combinatorial problems. So here we see that combinatorial problems, innocent combinatorial problems, can be at the heart of solutions to, once you solve them, it can be heart of solutions to problems in analysis, in algebra, in computer science, and so on. So is this surprising or this is expected?
I always like analytic number theory, and because this is still concrete, so I cannot understand abstract things, but analytic number theory is still something which you can grab. Because it's computation. Yes, once you learn a little bit complex function theory and so on, and then it's computations almost the same way with because we work also in probability theory, so sometimes we had to compute things, so that was not so far from my taste, and I always liked it. I am pretty sure I became a mathematician after hearing Turan's lecture, which was on mainly on analytic number theory, and it was given to mathematics physics teachers, which was very remarkable because there were 200 students, so it's you know that it is very hard to speak to a completely diverse audience when some of them, and he managed even the very it's maybe not a nice word, very bad one, or let's say mediocre one, because 200 students is a lot, could understand something, and good ones asked questions, and he gave out exercises, and it was completely beautifully built up lecture, a 1-year lecture. And then I actually decided to become a mathematician. Until that it was just by chance I got there, but then I decided then I might try. Now, so therefore analytic number theory was always in my head, but never did anything. Zero, absolutely zero in analytic number theory.
I have counter examples to the statement.
Then please send me references. Yes, I promise that, or send it to Anna, because she is the one who of course reads the emails. Maybe also she is the one who explains me the proofs. Just answering your question, I sit in a very high level class, analytic number theory, but introductory for graduate student. And then there was a beautiful proof, and then the professor who gave is one of the great number theorist. I will not tell the name for obvious reasons. And then he really talked about a very important result in analytic number theory. Now, I didn't understand completely the whole proof because it involved things which I did not know well, but at the very end, then he actually stopped when he arrived to the punchline. Then without it, everybody who is working on analytic number theory would have done. But now here comes the punchline that makes really the theory strong, and that is what moves the whole thing and proves the theory. And then I realized actually that was a kind of combinatorial idea, which if you give just independently to a combinatory, then would have solved it within a very finite time. So this is, I have this strong belief, though I cannot prove my belief, cannot prove that my belief is valid, that in this so-called high-level mathematics, they have all the language, they develop theory, but many times actually they hide. Then at the heart of the proof actually there is a not combinatorics but combinatorial idea. Even at that institute there is a famous one who actually I consider as a god. I mean, unbelievable. That's just not only magicians, much more than that. And then of course he knows everything. He really knows in a broad spectrum of mathematics. But many of these proofs actually boils down to a combinatorial idea. So now this is so that now the combinatorics is a little bit considered more serious subject. Now even the mathematicians who are working on some other much better established area start to understand that at some point even their results contain, a very huge part of the result contains a combinatorial, let's call it just combinatorial-like ideas. And I strongly believe it, though I just started to study some other part of mathematics, and this is the case. So it's a two-way street, most probably.